Harry Potter is actually not a magician, but is a well-trained physician from the future. Do you know a scene in Harry Potter where he goes through the wall and comes out to a different side?
Mm-hmm.
What is actually happening is he's actually quantum tunneling. Not teleporting to the other side, but quantum tunneling is inside. So there are three states of matter: solid, liquid, gas. Solid is very dense, so much density, and a lot of things. A lot of particles inside solid, very dense and packed to each other. Liquid is more spacey than solid, but still a little dense. Gas are not dense at all. They're just like this. What Harry Potter did and why he's from the future is because Harry Potter is solid. And Harry Potter, what he did is to go through the wall, and the only substance that could go through the wall is gas. He deformed himself to gas and made himself to gas and went through the wall and then formed himself again to solid. But we do not know how to deform ourselves or form ourselves back again. So that's why he's from the future. Also, there's a scene in Harry Potter where people disapparate. Disapparating is teleporting from here to here, not with the wall, just teleporting like. The same thing happened there. It's not quantum tunneling. It's not quantum, but he still used the form of deforming. He was solid, and then he made himself to gas, and then he formed into solid in another place. That is what Harry Potter did, and that's why he's a physician. Harry Potter is actually a physician. There is a house in between Canada and America. The house, in one part of the house, it's Canada. In one part of the house, it's America. And the house is exactly in the middle of the border of Canada and America. So when we go to the other side, we're in Canada, and we go to the other side, we're in America. Which means that we live in two countries at once. But look. Say that this is Canada. And this is America. The house is here. Right in the middle of the border of America and Canada. So this house is so small compared to these two biggest countries. So this house is just like this one, we're divided into America, this one we're divided into Canada, and this house is choosing everything. Which means, so what I want to say here is that there will be a very small thing that decides the big thing in space. So there is a place called T1. It contains Ton 618, which is the largest black hole in the universe. It also contains CWISE plus J1249, which is the oldest star in the universe. A lot of things in the infinite space T1. There's another space called T2, and this is called U. This is probability. Also, here is phi, called 공집합. And there is this. And there's also this. So this part is the whole part, which is except for this part, out of the U part, and this part is this, and this part is this, and this part is 5, which has no value. So you can express this as this. So what is the house is the T1 is right here. I mean, T1 is this infinite space itself, and T2 is this infinite space itself. That's why in one of my theory there is
너무 안 보인다. 다른 걸로.
who used Automorphic? 누가 샀어? 누가 샀어 이거? 동안이? 너무 유쾌하잖아. Because delta x is it's this representing u, so that's why delta x is actually always bigger even if we have all of this. So my theory is actually using probabilities. Should have known probabilities better when we are doing math with my mom. So this part, if we minus this part, then it's this part, and the u itself, delta x, is the largest, and this can never become larger than delta x. But this little spot, which is this, for example of the world in reality, and this one is just a little particle compared to T1. And this little particle is actually very important because inside the conventions, we have the string theory, which I watched in the video. Ding, and then it vibrates. That's a string. Like that. Musical notes. It starts from this side and ends in this side, maybe. And then when we ding, it creates a musical note. Like it doesn't actually create musical note, but we call it creating musical notes. So it ding, and it vibrates. So my theory is talking about the kinematics of light and colors. Isaac Newton loved it. So this little particle, what I was talking about, this little particle is actually, it is actually much important thing than how small it is. It decides if a particle should go inside the phi value, T2, T1, or the whole space. So this little particle, which is this, can divide into this or this, just like this can divide into this or this. So this part can be very small. In T1 and T2, the value is 1 to 1,000,000. So it's very small. This part is very small, almost close to phi. So we can round it up to phi using the Gaussian value. So this is very close to phi, which is nothing inside the name. So this part is this part, and this part is this part, and this part is this part. So inside here is dividing where it goes. can go here, here, or here. But then there's another country, and the house is like right here. Then this is dividing into this, or this, or this, or this. The spatial value is 1 bigger than actual reality, because the spatial value goes until infinity, which means that there are 2 infinities, and those 2 infinities can be the same encounter, which makes the total universe, which is delta x, bigger than the total value. But this, I didn't mean to represent it as a spatial value. I meant to represent it as, I was trying to write down the value for light and color and kinematics. But this is too hard, so I won't talk about it right now. Too deep inside other kinds of regions or fields of physics, like Isaac Newton's and quantum physics, special relativity, gravity, and more. So, why I talk about quantum tunneling today? Because this is the series 1 of lecture on kinematics and mechanics of quantum physics. This is series 1, first lecture. The first lecture, today's the first lecture, and today why we talked about quantum tunneling is because in the end I will reach here, where we can go until light and colors and Isaac Newton's gravity and special relativity, which we found in first, then general relativity, which later we can reach this place and try to theorize it even more and make it simpler. The best I've gone is this, but I am sure that it could be more simplified. Solid, liquid, the 3 state of matter. This is actually major in quantum tunneling. Epsilon is equal to Gaussian of Hamilton infinity t minus 1. Epsilon squared is equal to the Hamilton infinity. When we square this, there's nothing that comes out except 1. And when we square this becomes this chain rule. So now this one, we're gonna put I into it, introversials into it, and same with this, will lead to 0, and just this. So in that case, this can equal to the epsilon squared over Hamiltonian 0, double Hamiltonian 0 with the Gaussian representation. And we can actually put this down here, but it's more complicated and doesn't make a simplicity. So this was the series 1 of the first lecture of kinematics and mechanics of quantum physics.
Done?